So we have another RE model circuits, the voltage feedback bias circuit. So this is our voltage feedback bias circuit. So in DC, we have IC prime, we have IB, IC, and IE. We have to convert this one into an AC model and putting all your current. So we have IS, IF, IO prime, IO, IB, IE. Then we have your voltage input where we can get your input impedance and you have your output impedance. First is to determine the equation of your input impedance. Getting your input impedance is by your voltage input equation. So we have first to get the voltage input equation, which is beta RE times IB plus RE times IE. We know already that IE is equals to beta plus 1 IB. And our IB have two current pointing to your base, which is equals to IS plus IF. And your IF current, that is, we have a voltage where your IF came from, which is your BO, and it goes to your BI. Since it is a current, so we have to divide that with your resistance, which is your RB. Substituting all of this to your BI equation, so we have your beta RE plus RE times beta plus 1. Then times the equation of your IB, which is equals to IS plus IF, where IF is BO minus BI over RB. Then next, we have to get the equation of BO. BO is equals to negative RL times IO. And using current divider, we can solve for your IO, which is opposite resistance, that is RS over RS plus RL, then times IO prime. Then we have to substitute this to your BO. So therefore, BO is equals to negative RL in parallel with RCIO prime. But IO prime is equivalent to your IF plus beta IB. Since IF is BO minus BI over RB, so we have to substitute that one to your IO prime equation. Then substituting all of this to your BO equation, so we have negative RL parallel with RC times BO minus BI over RB, then plus beta IB. Then distributing negative RL parallel with RC to the quantity of your IO prime and combining all BO to your left side. So we have BO plus RL in parallel with RC all over RB times BO equals to positive because we have a negative RL in parallel with RC times negative BI. So we have now RL in parallel with RC over RB BI. Then we have a negative RL in parallel with RC minus IB. So in this equation, we have now BO and BI, but there is still an IB variable. So we have to express these IB variables in terms of BI. So we can get your IB by using your voltage input equation. So we have beta RE plus RE times beta plus 1 IB. So therefore, IB is BI over beta RE plus RE times beta plus 1. Then we have to substitute that to the equation of your BO. Then getting the least common denominator on both sides. Then cross multiply. So we have now BO equals to BI and this equation. If we have to get the ratio of BO over BI, so that will be our voltage gain. So for the equation of BO, BO is equals to voltage gain times BI. So since our BI equation in the input impedance is equals to this equation, which we have BO minus BI, then we have to substitute your BO, which is voltage gain times Bi to your equation of Bi. So we have now this equation, beta Ra plus Ra times beta plus 1 times Is plus voltage gain Bi minus Bi over Rb. Or we can rewrite this equation as voltage gains minus 1 all by Bi. Then we have to distribute your beta Ra plus Re times beta plus 1 to that Is plus Eb minus 1 times Bi over Rb and combine all Bi to your left side and get the least common denominator of your Bi. Then since your input impedance, that is Bi over I input, where I input is equals to Is, so therefore this is our impedance input or impedance I. To get your impedance In, we have just to add your Rs to your impedance I. Then for the output impedance, by setting Bs to 0, so we have Rs in parallel with your beta Re plus Re, then plus Rb in parallel with your Rc and in parallel with your Rr. So that is our output impedance. Then for the voltage gain, that is Bo over Bs, and we know already the equation of your voltage gain, which is Bo over Bi. So for EBS, that is the same as Bo over Bi times Bi over Bs. So the ratio Bi over Bs, that is equivalent to your input impedance I over impedance In. So therefore, your EBS is equals to voltage gain, which is Bo over Bi times impedance I over impedance In. For the current gain, that is EIS equals to IO over IS, we can get your IO at your BO equation, which is negative RL times IO. So therefore, IO is equals to negative BO over RL. Your IS can be at your BS equation, it is impedance IN times IS, so IS is BS over impedance I. Substituting this one to your EIS, so your current gain is now negative B over RL times impedance IN over BS, or that is equivalent to negative EBS times impedance IN over RL. So we have this example. You have to solve for your impedance IN, output impedance, EBS, EIS, and BO if BS is equivalent to 10 millivolts. So first, we have to get your RE using the DC biasing. So in your DC analysis, we have this current, IC prime, IB, then IE. So using KVL, on your input side, we have 12 minus 2.2 KIC prime minus 220 KIB minus voltage base emitter, then minus 750 IE. IC prime is equals to IB plus IC. And also IA is equals to IB plus IC, therefore IC prime is equals to IE. And we have to express IB in terms of IE. So since IA is equals to beta plus 1 IB, so therefore IB is equals to IE over beta plus 1. Since our beta is 99, so we have now 100. So we have 220 key over your beta plus 1, so it is 100. Then plus 2.2 key plus 750. So this is the value of your IE. Solving for your RE, that is 26 millivolts divided by this IE. So we have an RE, it is 11.84955752 ohms. Getting your beta RE, we have to multiply it by 99. So we have 1173.106195 ohms. So from your DC analysis, we go now to your AC analysis by converting your amplifier into an AC model. So this is the flow of your current, your voltage input, where we can get your input impedance and your output impedance. So for your input impedance, first we have to get your equation of your VI. Then we have to express IA in terms of IB. And since IB has two current going to that branch of the circuit, it is IS plus IF. And our IF, that is your IF is from your BO going to your BI over the resistance of your RB. Then therefore BI is equals to beta RA plus 750 times 100 times IS plus BO minus BI over 120K. Since BO is equals to negative 2.2K in parallel with 2K times IO prime, then IO is equals to IF plus beta IB. We know already the equation of your IF. Then substituting this one to your BO and combining all BO to the left side, then getting the equation of your IB through the BI equation, substituting that one to BO equation, then get the least common denominator between BO and BI and cross multiply. So we have now your BO over BI equals to your voltage gain, which is equivalent to negative 1.3411222043. So therefore, your impedance I is equals to 30,639.7488 ohms. Then for your impedance IN, we have just to add your RS, which is equivalent to 1K. So therefore, we have 31,000 or 31.6397488 kilo ohms. For the output impedance, rating BS to 0, so we have 1K in parallel with your beta RA plus 750 plus your RB, which is 120K in parallel with 2K and 2.2K. So this is your output impedance. Voltage gain, that is B over BS, or that is voltage gain times impedance I over impedance IN. Since we have AB already, so therefore, EBS equals to negative 1.298734789. Then solving for your BO, it is ABS times BS, where BS is 10 millivolts. So we have negative 12.987344789 millivolts. And for your current gain, we have to use the value of your ABS. Then since ABS equals to negative 1.298734789, then our input impedance or impedance IN is 31.6397488 kilo ohms. So therefore EIS is equals to 0.24545822123. And that's all for voltage feedback bias circuit.